Hey everyone, in this video we'll learn how to find the domain and range of a function. So what we'll do is we'll start with this function, f of x equals x squared. F of x equals x squared. And we will find the domain and range of this function. So the domain is the set of all possible inputs. What can the inputs be? And the range is the set of all possible outputs. What can the outputs be? What values can they be? Okay, so let's take a look at this function right here, f of x equals x squared. And let's think, what can x equal? What can the inputs, our input x, what can it equal? Well, we can put 0 in there, f of 0. So f of 0, because that will come out to 0 squared, which gives us 0. So 0 works. We know 0 is fine. F of 1 comes out to 1 squared, which gives us 1. So we know 1 is fine as well. We can also do negative 1. F of negative 1 equals negative 1 squared, which is 1. So negative 1 works. Can we input negative 2? Sure we can. F of negative 2 equals negative 2 squared, which is 4. So we're allowed to input negative 2 as well. So it looks like for the domain, there is no limit. We can put in any real number. So just taking a look at the function x squared, x being any number, we can square any number. There's no limit to what numbers we can square. So that means our domain has all real numbers. The domain of our function, f of x, is all real numbers. It doesn't matter. We can input any real number into f of x. So it's all real numbers, and the way to represent this using interval notation, it's every number from negative infinity to positive infinity, closing both with parentheses. So that's how you represent the domain in interval notation from negative infinity to positive infinity. All real numbers. Okay, so that's the domain. The domain could be any real number. Now let's talk about the range. What is the range? So the range is the set of all possible outputs. So we know that x is an input. So we know that x is an input. What is the output of a function? The output of a function is f of x, right? F of x. And let me write that over here. Well, let me write that here as well, f of x. And let me also write it over here, f of x. Now, what did we say f of x equals? F of x equals x squared. X squared. So if we just try a few numbers, let's try f of 1, f of negative 1, f of negative 2. Let's just try these three inputs. So what's f of 1? Well, that's 1 squared, which is 1. What's f of negative 1? That's negative 1 squared, which is also positive 1. What's f of negative 2? That is negative 2 squared, which is 4. Okay, so it looks like we have some possible range values. Our range can include 1. Our range can include 4. In fact, our range can include every positive number. But the issue is, if we take a look at our output f of x right here, our output f of x equals x squared, any number squared, any real number squared is always positive. Okay, if you square any real number, it will always be a positive number. So x squared must always be a positive number. Of course, some imaginary numbers, if you square them, then you can get a negative number. But here in this function, we're dealing with real numbers. We're only talking about real numbers. So x squared is always positive. It's always greater than 0. And what did we say x squared was? We said x squared was f of x. So that means f of x is greater than 0, which means our range has to be greater than, or rather greater than or equal to, greater than or equal to. It can equal 0, because we know that f of 0 equals 0 squared, which equals 0. So greater than or equal to 0. So x squared can't be negative. It must be positive, or it could also be 0. So f of x must be greater than or equal to 0. And to represent our range using interval notation, we go from 0 to positive infinity. And we are going to use a bracket to include 0, because this is a or equal to bar. And then for the infinity, we'll use a parentheses. So x is every number greater than or equal to 0. That is the range. The range is every number greater than or equal to 0. So that's how you find the domain and range of f of x equals x squared. Right here, that's the domain, and that's the range. So the domain is all real numbers, negative infinity to infinity, and the range is 0, including 0, all the way to positive infinity. Perfect. So let's go ahead and move on to another function. Let's say we had the function f of x equals x plus 1 over x minus 3. Okay, so we have a function that is rational. We have x plus 1 divided by x minus 3. So the important thing here when you encounter rational functions is you know that you cannot divide by 0. Anything divided by 0, so if we have a number, let's just say we have 4 divided by 0, that is a very big no in math. You cannot divide anything by 0. So dividing by 0 is very dangerous. You can't do that. So what does that mean for us, dividing by 0? Well, we know right here x minus 3 cannot be 0. We know that x minus 3 does not equal, so this is the not equal sign, it's an equal with the bar through it. X minus 3 cannot equal 0. Okay, so x minus 3 can't be 0. Let's actually solve for x right here. And so to do that, we'll add 3 to both sides. So we have x cannot equal 3. So x cannot equal 3. Okay, so let's keep that in mind. X cannot equal 3. And let's talk about the domain and the range. The domain and the range. Okay, the domain and the range right here. And let's talk about the domain. So what are all the possible x values, all the possible inputs? So our input in this function is x. What can x be? Well, we know what x can't be. X cannot be 3. So x can actually be any number except 3. So how do we represent that in interval notation? Well, x can go from negative infinity to 3, but not including 3. So we'll use a parentheses. Or, so we'll use this U symbol, this union symbol to represent or. So or, and then we move this. The input can go from 3, again, not including it, so we're using the parentheses, to positive infinity. That is how we represent our domain using interval notation. So, in other words, the domain x, our input can be any number except 3. As long as it's not 3, it can be any other number. And that's the important part there. So that's the domain, and now the range. So the range of f of x. What values can f of x be? So let's think about this. Let's try to input f of 1. So f of 1 is So let's just color it like this to make it easier. X plus 1 over x minus 3. X plus 1 over x minus 3. And then that's 1 plus 1. So f of 1 is 1 plus 1 over 1 minus 3. What's 1 plus 1? That's 2. What's 1 minus 3? That is negative 2. 2 over negative 2 is negative 1. Okay, so we know our range can include negative 1. Cool, so that's f of 1. Let's try more values. What about f of 0? So f of 0, 0, so let's just do this. 0 plus 1 over 0 minus 3. 0 plus 1 over 0 minus 3. This comes out to 1 over negative 3, so negative a third. Okay, so far we know our range can be negative values. Can it be any positive values? So let's go ahead and try. We will go ahead and try f of 5. So f of 5 equals 5 plus 1 over 5 minus 3. What's 5 plus 1? That's 6. Over 5 minus 3, that's 2. So 6 over 2 equals 3. So it can be positive values as well. So it looks like our range can actually include all real numbers. And how do we represent all real numbers using interval notation? That is simply negative infinity to positive infinity. And there we go. Perfect. Negative infinity to positive infinity. Okay, so let's go to one more type of function. So f of x equals the square root of x minus 10. So f of x equals the square root of x minus 10. What are the domain and range of this function now? So the domain and range of this function. Okay, let's start with the domain. What values can x be? So what values is x allowed to be? Well, we know we have a radical here, square root. And remember, we're dealing with real numbers. So we can take the square root of positive numbers. We cannot take the square root of negative numbers. That's not allowed. So in other words, this big square root that we're taking right here, square root of x minus 10, that means x minus 10 has to be greater than or equal to 0. So x minus 10 must be greater than or equal to 0. And then if we go ahead and solve for x, so we can do that by adding 10 to both sides. So add 10, add 10. This means that x must be greater than or equal to 10. So x has to be greater than or equal to 10, and that's the range, or that's the domain right here. X is greater than or equal to 10. And how do we represent that in interval notation? We will do a bracket, 10 to infinity, and parentheses. So this is the domain. X is greater than or equal to 10, or 10 through infinity, bracket, parentheses. That is our domain. So let's go ahead and just move that a little bit. So we know that that's our domain, but now what's our range? Okay, so our range, what can f of x be? Well, if you take a look at this entire thing, which is f of x, the square root of x minus 10, whatever the square root of this is, it must come out to a positive number. So this entire term right here, it must be greater than or equal to 0. So f of x, that means f of x right here, because f of x is this term. So just to write it down, the square root of x minus 10, the entire thing, because we're taking the square root of it, it must be greater than or equal to 0. But what is the square root of x minus 10? That is just f of x. So we can replace this thing with f of x. Let's go ahead and do that. F of x. So f of x must be greater than or equal to 0. And f of x is our output. So that's our range. Our range must be greater than or equal to 0. So our range must be greater than or equal to 0. And how do we represent that in interval notation? We'll use a bracket, 0 to positive infinity, close bracket. And that is our range, from 0, including 0, to infinity. So that's how you find the domain and range of this function, the square root of x minus 10, f of x. Excellent. So let's begin graphing just a few functions. So let's go ahead and graph a function like this. One, two, three, four, 5. -1, -2, -3, -4, and -5. 1, 2, 3, 4, 5. -1, -2, -3. Okay. So let's try to find the domain and range of a certain set of functions. Let's start with a constant function. Let's say we had f of x equals 3. So f of x equals 3 is drawn just like this. Because we know this is a constant function, so this is f of x equals 3. And let's find the domain and range. So the domain, how you find the domain by looking at the graph, you'd look at the x-axis right here. So take a look at the x-axis, and we see that this blue line right here, our function, which is this blue line, extends to every x value. It can be x equals 1, it can be x equals 3, x equals 5, and all the way to infinity. It can be x equals -2 right here. So right here, it can be x equals -3 right here. It can be x equals -5 right here, all the way to negative infinity. So the domain of this, I'll just represent in D, is negative infinity to positive infinity. Okay, now what's the range? The range here, so if you take a look at it, let's take a look at the y-axis now. What y coordinates can this line have here? Well, at every point here, its y coordinates will always be 3. This line only exists on y equals 3. So the only possible range here is 3. The range is 3, and that's it. So that is the domain and range of a constant function. The domain can be any real number, and the range is simply just the constant, which in our case is 3. Great, so now let's talk about an identity function. Let's erase this. Let's talk about how to find the domain and range of an identity function, which is represented as f of x equals x. So let's just draw that. It's just going to be this line, f of x equals x, or y equals x. Okay, let's draw that straight line. There we go. F of x equals x. Okay, what is the domain of this function, f of x equals x? So let's take a look at the x-axis. And as you can see, x can be any number. It could be 1, because it has a place for it on the line right here at this point. It could be 2, because it has a place right here on this line. It could be 4, because it has a place right here on the line. It could be -2, so it has a place right here. It could be -5, because it has a place, if you extend this a little bit, right here. So x can be any real number again. So the domain is negative infinity to positive infinity. Good, now what about the range? So the range, if we look at the y-axis now, what values of y can land on this line? So y can be 1, because there's a place for it on the line. Y can be 2, y can be 3, y can be 4, y can be 5, y can be negative 1, it can be negative 2, it can be negative 3, and beyond. So y can be every positive number, it can be every negative number, it could also be 0 right here. So y also has a range of all real numbers from negative infinity to positive infinity. So the domain and the range of f of x equals x, both the domain and the range are all real numbers. Great, now let's talk about an absolute value function. Let's go ahead and graph that. Let me just go ahead and erase all this. And then we'll go ahead and talk about the absolute value function, which is going to be represented as f of x equals the absolute value of x. So we'll write that down. F of x equals the absolute value of x. Okay, so what does that look like? Let's go ahead, let's use orange for that. So it's going to have that V shape, like this. Let me just draw a better line. So it's a line on one side. And let's plot these points right here. And it's going to be a line on the other side. So this right here, this is f of x equals the absolute value of x, right here. Okay, so what's the domain of this function? What x values can this be? Let's just look at some of the x values. We have x equals 1, so it has a place for it right here. X equals 2, there's a place for it right here. X equals 3, there's a place right here. X equals 4 right here, and so on. All the positive numbers. X is 0, there's a place right there, so that's fine. And all the negative numbers as well. X equals negative 2, there's a place right there. X is negative 3, there's a place right there, and so on. All the negative numbers as well. So, in other words, the domain is all real numbers. So negative infinity to positive infinity. Now what's the range? So for the range, we'll take a look at the y-axis. And y equals 0, so right here, it has a place for it, so y can be 0. Y can be 1, because there's a place for it right here and also right here. Y can be 2, because there's a place for it here and here. Y can be 3, because there's a place here and here. Good, so y can be all the positive numbers, and 0. Can y be any negative numbers? Like, can y be negative 3, for example? Well, no, because at y equals negative 3, it does not touch the function f of x in orange. So it doesn't touch the function, so y can't be negative 3, y also can't be negative 2 or negative 1. In fact, y can't be any negative numbers. And that makes sense, taking a look at it. The absolute value of a number is always positive. It can't be negative. It's always 0 or a positive number. So the range, just by looking at this graph, is including 0 to positive infinity. That's the range of f of x in this case. Now let's talk about quadratic functions. So let's erase all this. And let's go ahead and talk about quadratics. Okay, let's erase that. So quadratic functions are represented as f of x equals x squared. And let's go ahead and plot that in blue. So it goes like this. 1, negative 2, comma 4. And it's a little curved. It's shaped like a parabola. That's the type of shape it is. Let me just redo that part. Okay, there we go. So this parabola right here, this is f of x equals x squared. So the same thing, we're going to find the domain and range by looking at the graph. The domain and range. And the domain, we're going to look at the x-axis right here. Can x be 1? X can be 1 right there. Can x be 2? X can be 2 right there. Can x be 3? X can be 4. X can be 5. Yes, if you extend this graph large enough, so far we don't have too much space, but if you extend this graph using these arrows to infinity, x can be any positive number. X can also be 0, because there's a spot for it right there. And x can be any negative number, because if you look at -2, it lands right there. -1, it lands right there. So x can be any real number. So the domain is any real number, -infinity to +infinity. Now the range. So take a look at the y values on the y-axis. Y can be 0, so that's fine, it lands right here. Y can be 1, because it lands right there and there. Y can be 2, because it lands here and here. Y can be 3, because it lands there and there. And y can be 4, because it lands there and there. So y can be any positive number and 0. But can it be a negative number? Can y be -1? Well, no. It can't be -1. In fact, it can't be any negative number, similar to the absolute value function. The quadratic function, its range is only from including 0 to infinity. So that's the domain and range. The domain is all real numbers, and the range is 0 inclusive through positive infinity. So now let's talk about the cubic function, so x to the third. Let's go ahead and draw that. So f of x equals x to the third. So it is drawn like this, so 1, 1, 2, 8, which is all the way up there, 0, 0, -1, -1, -2, -8. So it's shaped like this. F of x equals x squared, f of x equals x cubed. And let's find the domain. So the domain on the x-axis, what x values can f of x equals x cubed be? Well, it can be all the positive numbers, because there's a spot for all of them on the graph. And if you extend this large enough, you can see it lands for 3, 4, 5. And it can be any negative number as well. There's a spot for all of them on this graph. And it could also be 0 right there. So the domain can be any real number, -infinity to +infinity. And the range can also be any real number, -infinity to +infinity, because the range, looking at the y-axis, any of these y values will land on this graph. There's a spot for 1 on the y-axis, there's a spot for 2, 3, 4, every positive y value. There's a spot for y equals 0, y is -1, y is -2, y is -3, every negative y value. So the domain and range are both all real numbers for f of x equals x cubed. Now, let's talk about another type of function, the reciprocal function. Let's go ahead and erase all this. Let's erase that graph as well. Let's make it as neat as we can. Let's undo that. Okay, so f of x, the reciprocal function, f of x equals 1 over x. So how this is drawn, let's draw it in blue. So 1 comma 1, 2 comma a half, 3 comma a third, 1 half comma 2, a fourth comma 4. It is drawn like this. Okay, and then the negative side, so negative 1 comma 1, that comma 2, comma 3. Okay. That is drawn like this. Okay. So this is the function. F of x equals 1 over x. What is the domain and range of this function? So the domain of this function, what values can x be? Well, we know x can be 1, because there's a place right there. X can be 2, there's a place right there. X can be 3. X can be all these positive numbers. X can be even be these fractional numbers. X can be a half right here, because there's a spot for it right there. X can be a quarter, because there's a spot right there. And negative numbers as well. X can be negative 1 right there. X can be negative 2 right there. X can be negative 4 right there. So x can be any positive or negative number as long as x is not 0. Because at x equals 0, this function is undefined. And that makes sense because going back to our earlier example, f of 0 would be 1 divided by 0, which is a big problem in math. We can't divide by 0. So that means our domain cannot be 0. It can be every real number except 0. So how do we represent that? It is negative infinity to 0, using a parentheses, union 0 to positive infinity. So that, and then we'll close the parentheses. So that is the domain. It is every real number except 0. Now, that's the domain, but now what's the range? The range is actually the same. It's also every number except 0. So negative infinity to 0, union 0 to positive infinity. If you take a look at on the y-axis now for the range, y can be all the positive numbers. It can be 5. So right here, it could be 5. It could be 4. It could be 3, 2, 1. It could be a half right there. It could be negative 1. It could be negative 2, negative 3. Y can be any positive or negative number, but it can never be 0. It can never be 0. And that makes sense because if you replace f of x with 0, so 0 equals 1 over x, and then if you try to solve for x, you won't be able to. Let's go ahead and try to solve for x. So to do this, we can just multiply both sides by x. So x times 0 equals 1. But what's anything times 0? Anything times 0 is 0. And then we have this nonsensical equation, 0 equals 1, which we can't do. So 0 does not equal 1. So 1 divided by any number, it can never be 0. That's why our domain and our range are both every real number except 0. So that's how it works for a reciprocal function. And now let's just talk about our last function, a square root function. So let's erase all this. Let's put that back, negative 2. Just try to erase as much of this as neatly as we can. Okay. There we go. So f of x equals the square root of x. So let's draw this in blue. So f of x equals the square root of x. So here, 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 and it goes like this. F of x equals the square root of x. Okay, so what's the domain of this function? So as we could see right here, the domain, it could be 1, it could be 2, it could be 3, because there's a spot for it on the graph, 1, 2, 3, 4. It can be every positive number. It can also be 0 right there, because that's where it starts. But it cannot be negative. So the domain cannot be negative. So it only goes from 0 to positive infinity. So including 0 to positive infinity. That's the domain. Now, what's the range of this? So the range of this, well, let's take a look at the y-axis for the range. It can be 1 right there. It could be 2 right there. So 2 right there. It could be 3. It could be 3. It could be 4. So the the domain, or rather the range, can be every positive number right here. And it could also be 0 as well. But no negative numbers touch this graph. No negative numbers on the y-axis, -1, -2, -3. None of them can touch this graph. So our range is also from 0 to infinity, same as our domain. So our domain and range are all numbers greater than or equal to 0. And that's how you find the domain and range of all these different types of functions. I hope this video helps, and if you have any questions at all, please leave them down in the comments below, and thank you for watching.